next we are going to estimation of grade. The grade and grade of resource. So basically grade is the metal content. You can say simply you can say the metal content. Okay, and that is there are other terms: tenure, assay. Tenure is purely used for metals. It is a old concept. Now tenure is a old concept. Okay, tenure is purely used for metal. Okay, so basically tenure your indicates the percentage of metal. Okay, assay is also the percentage of metal. It is a very irregularly used term, assay value. Okay, and this grade in the old concept, this grade is used for both metals and not non-metals. Okay, metals and non-metals. But nowadays this tenure is obsolete. Grade is only used. But earlier days, grade is a qualitative term. Grade was a qualitative term. Okay. What is the qualitative term? Like it expresses the metal content. Also it expresses the impurity content. Impurity contents. Okay. Like for example, when there is high alumina in a iron ore, that is very harmful to the blast furnace. Alumina means Al2O3. Okay, simply. If Al2O3 content is high in a hematite, particular hematite, like it will be increased from 2%, greater than 2%, then it is harmful for the blast furnace. So when a buyer goes to the mine to buy some ore, he asks what is the alumina content. So if in this Singhum iron ore, the alumina content is greater than 2%. Okay, so accordingly blast furnaces are designed. Blast furnaces are designed to bear that effect. Okay, so this what I was telling, yes. So basically, if a hematite, consider a hematite, high grade hematite, like it contains 70% of Fe, but it contains of 10% of Al2O3, then it is, we will call it as low grade. In the earlier context, okay, sorry, in the older context, older grade concept. But nowadays, these tenure concepts these are all obsolete. Only grade we are using is 70% iron. That is the grade. Okay. So that is the grade. Now, so you forget everything I told you. Okay. Now you just remember that grade means the metal content. Okay. So estimation of grade. First we know the cutoff grade. What is cutoff grade? We have known. Now this minimum width. So this minimum width is nothing but the minimum space to work. Space to work in a mine. Okay, like okay, so basically a minimum of it, like the minimum width or it is also called as minimum stopping width. Okay, minimum stopping width. Okay, stopping means to take out the ores and a empty space to left behind. That is stopping. That is process of stopping. There is various processes of stopping. So that is not in your syllabus, or you can go with the books are there. You can go with for stopping processes. That is not in your syllabus. Okay, and it doesn't come in any exam also. So there are stopping processes: rectangular stopping, pillar stoping, cotton pillar stoping, okay, brace stoping. These are processes. So stoping is basically to remove the ore or to mine the ore and leaving behind a empty space. Okay. So in minimum width is the space required, like is the space required to work. Okay, if you are doing in underground mining or open cast mining, in open cast mining it is very wide space available. Okay, in underground mining it is very less. So minimum of 3 meter is required to work, 3 meter wide space to work in a mine. Okay, but it depends on the ore type. Okay, ore type. It is a vein type or disseminated type. You require less depth, less exposure. Okay, but in coal areas, you will get you need a great exposure. Okay, so these are like varies with the ore type and type of deposit also. How these deposits are distributed in the litho area, litho unit. Okay, so this is minimum width. Then cutting factors. What are the cutting factors that are used for calculating the grade? Okay, for calculating the grade, some cutting factors are used. Why these cutting factors? Because I am taking a homogeneous sample. If you will take a homogeneous sample, that day I was telling you why sampling is done like this range from pit. Okay, after that we go for coning and quartering to make the sample homogeneous. Okay, the sample will look like it will represent the whole deposit or the large portion from which that small portion is taken. So the sample should be homogeneous. So if what happens when you are taking the sample, there is a particular chips which is very high grade. Okay, very high grade. It comes in the sample. Then it will automatically increase the grade. Automatically increase the grade. You are getting it now. So I have taken the sample like it shows 5% of zinc. Okay. But what happened? A zinc nugget. It is called as nugget. Huh? Nuggets. So this zinc nugget with almost 20 to 30% zinc is there. It came and it included in the sample. It increased the grade to 10%, 12% of zinc. Okay, but this is due to the nugget only. This will not represent that particular large portion. Okay, so that's why we have to cut these factors or we have to cut these nugget values. So these are called as nugget value. Okay, these values are considered to be erratic and are designated as nugget values. Okay, or you can like this, you will get some nuggets. Okay, you will get some nuggets in the mines. So you have to, based on that nuggets, you have to standardize a cutting factor. Okay, that the ore if the limit is above this percentage, then I will cut that factor. Okay, during the reserve estimation. Cutting factor. These are cutting factors. You are getting it. So this is cutting factor. Next concept. Okay. Now we are going to calculate the average grade. So you know I am taking this ore and I have analyzed. This is 2% of zinc. Okay, and I have taken this portion. This is 3% of zinc. There are multiple portions are there. Okay, so I have to find the average grade. What is the average grade of this whole deposit? Okay, consider this L1, L2, L3, L4, L5. It is like it may be length, it may be area, it may be volume. Anything it may be. You have to do one thing. You have to multiply this L1 with its grade plus L2 with its grade plus L3 with its grade, so on, L1, Ln into its grade Gn. Okay, it may be area divided by L1 plus L2 plus L3 plus Ln. This is the simple formula for average grade. Okay. If it is areal basis, A1 into G1 plus A2 into G2 plus A3 into G3. Okay, AN, GN. Then A1 plus A2 plus A3. If it is volume, area is basically not required. We calculate either length or volume. Okay, if it is volume, then average grade will be V1 into G1 plus V2 into G2 plus V3 into G3. Okay, plus Vn into Gn divided by V1 plus V2 plus V3 plus Vn. Okay, so this is the process of calculating average grade. Okay, you are getting it, everyone? Okay, so based on that, solve this question and tell me the average grade. So basically, you have to multiply these things. Okay, multiply and divided by this thing. Okay, what is the total length? टोटल लेंथ कितना निकला सबका? No, 12.4, 11.95 maybe. Yes, 11.95 is the total length. Calculate again. अब तुम्हें कुछ नहीं करना था बस आर करना था, उसमें भी तुम गलत कर ली.
Sir, by mistakenly I have taken that 0.75 also. Sir, it is written in the mark between 31.35 and 43.30. So we will not add that one, 31.35.
Yes,
That is
you have to add
3.76.
31.35 to 32.60. So this thing, this is below 31.35. So this is not mineralized, na?
Yes, sir.
Ah. Okay, so your grade will be something like 7.56 or something. Okay, okay. So we are going to next. This thing you have to mark that which portion is mineralized. Which portion is mineralized? Okay, which portion is mineralized? You have to mark. This is like this is told 31.35 to 33.30. So this is 31.352 means starting from 31.35. So below 31.35 it is not mineralized, and above 33.30 it is non-mineralized. So you will not count that. Now you calculate the grade at a 3% zinc cutoff grade. So what will you do? Tell me, someone. What is the simple process to calculate the grade in the 3% cutoff? What is the simplest process? What you have to do? You have to just eliminate those lengths or those samples which are less than 3% in the mineralized zone. In the mineralized zone, we have to just eliminate that part, and you have to calculate. Okay, So you have to just eliminate this thing. After that, you have to calculate the grade. This is because this is below 3%. This is below 3%. That's why we have eliminating. We are eliminating this thing. Okay. So this is the process by which we calculate the cutoff grade. Grade below cutoff grade. Grade we including the cutoff grade. Okay. So this is average grade. Okay. So next is some terminologies are there like mineable grade. Mineable grade means so the like आफ्टर द इंटरनल एंड एक्सटर्नल डाइल्यूशन जो भी है उसको ऐड करने के बाद जो the thing we mine, okay, the thing we mine is called as mineable grade after including all the internal external dilutions. Okay, runoff mine grade is generally after blasting. What they do, they take samples and get get an overall idea that this much amount of this much grade will be there in this area. They have planned with the drill holes when during exploration, but now they have blasted that area. So after blasting that ores extracted, the ores are like spread in the whole area. So in that area they take samples. After taking the samples, so ROM sampling, I have told you ROM sampling, that is the thing. So they take that ore, so to get an idea that key what will be the probable grade. Basically the runoff mine grade is higher than normal grade. Okay, it is higher because it consists of large amount of blocks. Na? After processing it reduces. Okay, 5 to 10% higher. Okay, so it is lowered after processing. So this is runoff mine grade. And mill feed grade or tailing grade, it is the grade which a mine like sells to the plant. Okay, this plant purchases and gives to the mill. Okay, it feeds to the mill. Like mill means that plant or that blast furnace. Okay, it is poured in the blast furnace to smelting. That is the mill feed grade. Okay, so the tailing grade is mill feed grade is given in the plant. Okay, feeded in the plant. You can say feeded in the plant. Mill feed grade in the plant. In the plant, what they do? They some plants what they do. Some plants take crossed product, or some plant cross their own ores. Okay, like mines after extracting the ores are like big blocks. Okay, big blocks, big. So what they do, they screen according to size, and if the mines has a crosser, then they cross according to size. For iron ore, the screening size is 1040 and the crossing size is 518 or some in some area 520 mm, huh? For iron ore. So these things, after removing this thing, all the things are called as fines. Okay. Below 10, it is called as fines. Below 5, it is called as fines. This cross product has higher value, screen product has lower value. Okay. Because in crossing, you are expending your fuel and other things. Screening also expending energy, but cross product has more value. So these things are fed into the plant. Okay, these plants what they do, if they are taking screen product, they cross their product also. Okay, they cross their product. These plant take this product. After taking this product, they wash and they treat. Okay, treat and form these what sponge iron. Sponge iron. Sponge iron means this iron, after a process, what happens? The volatile materials, the silicates, the carbonates inside the ore, they are removed from that particular chips. Okay, that looks like a sponge. That's why it is called a sponge iron. This sponge is fed into the blast furnace. Okay, blast furnace. Some plants are there who take fines. What they do? They feed these fines to this plant, and fine, these are very fine materials. They feed these fines to the plant, and after this removal of these carbonates, silicates, carbon materials, okay, what they do? They make it as pellets, round things, okay, spherical things, pellets, iron pellets. So two types of raw material is there after processing. One is sponge iron, one is pellet. Okay. So this is the feeding plant. Okay. So during after feeding, there are certain processes like washing, okay, crossing. These are processes. During these processes, the grade is continuously analyzed through softwares. Nowadays, softwares are used for analyzing the grade, the size and the grade. Okay, so this is called as telling grade. Telling grade is after feeding during processing. Okay, telling grade is after feeding during processing. Getting it clear?